Hello everyone, and thanks for watching Edupedia World Videos. In this video, I will show you the solutions to the problems in the physics part of paper 1 of the 2015 JEE Advanced question paper. So let's look at the first question. We are given a double slit experiment in which the first half, the bottom half of the experiment is done in water. So the rays passing from S2 to this point will actually be passing through water, whereas the rays passing from S1 to this point will be passing through air. The positions of the maxima on the surface of water are given by this particular relation where lambda is the wavelength, and we want to find out the value of P. So essentially we want to find out what the position of the mth maxima is, and that formula will be something like this, and from that we will be able to calculate the value of P. Let's say this is the first slit and this is the second slit. And this distance, this whole distance is x. This distance is d, this distance is d. This is air, so refractive index is 1 here. This is water, so refractive index is equal to, it's given to me that it's 4 by 3. So two rays will be going, one from this slit to this point and the other from this slit to this point. Now these two lengths are equal because these two triangles are congruent, but still, even though the path difference is 0, there will be some optical path difference because the optical path is not the same as the path, right? So this will travel a distance equivalent to this length, but this will travel a distance equivalent to a length of 4 by 3 times this distance if it were traveling in air. Right, so I'm sure you know the concept of optical path. So the net path difference delta x will be this particular length times 4 by 3 minus plus d squared. So this length is the same as this length. So in this case the optical path is n times x. So this will be the path difference. Right, this has to be equal to m lambda, an integer multiple of lambda for constructive interference, that is for maxima. This means root of x squared plus d squared by 3 is equal to m lambda, which gives me x squared is equal to 9 m squared lambda squared minus d squared. Right. And we know that x squared is p squared m squared lambda squared minus d squared. So p square has to be equal to 9. So p has to be equal to 3. This is the answer to this question. Let's look at the next one. Okay, this is a question based on geometrical optics, and we are given a particular setup, and we are asked if the setup is kept in a medium of refractive index 7 by 6 as opposed to a refractive index 1, which is air, what is the difference in magnification? What is the ratio of the two magnifications? So the first thing to do in questions regarding geometrical optics is to draw a figure very clearly, because that's half the battle. In geometrical optics, most of the errors come from not drawing the figure properly. So this is my concave mirror. Sorry. And this is my lens. Both have focal lengths of 10. Right, and we are given that there's an object kept 15 centimeters away, and this would be the focal length 10 centimeters. Right, and we need to find out the image created after both the reflections. Now the first thing to note is, from this object light will be going in all directions, towards the left and towards the right. The light that will be going towards the right, some of it will pass through this lens and go towards the right. It will not come back. So that light will never ever touch this mirror. So the only way in which we have reflection and refraction both is by the light going through the left. That light will first reach the mirror and then it will get reflected and then refracted through the lens. So the first we will have to do reflection by a mirror, and then later we will do refraction by a lens. So for the mirror, the formula is 1 by v plus 1 by u equals 1 by f. So that will be 1 by v plus 1 by 15, because u is 15 positive in this case, the right direction is positive, is equal to 1 by f, and f is again positive in this case, which is 10. So it gives me 1 by v is 1 by 10 minus 1 by 15, or v is equal to 30 centimeters. Right. So this distance, if this is 15, this total is 30. This is where the image is formed. And we know that the magnification for a mirror is minus v by u. So if v and u are both positive, the magnification is negative, and in this case it is minus 30 by 15, or minus 2. So the image of this object on this mirror is an object of double the height and at a distance of 30 centimeters. Now this image will be the object for this refraction. So we want to find the image of this, right? So for the lens, the formula is 1 by v minus 1 by u is 1 by f, and we are given this total length is 50 centimeters. And if this is 30, this remaining length becomes 20 centimeters, right? So in this case, we can say 1 by v. Now we want minus 1 by u, but u in this case is minus 20, because again we always take the right direction, the direction of the principal rays, to be the positive direction. So u is minus 20 in this case, equals 1 by f, and 1 by f again, f is positive 10 in this case because it's a convex lens. So 1 by 10, which gives me 1 by v plus 1 by 20 is 1 by 10, or it gives me v is equal to 20. Now this v and this v are different. Technically I should be using v1 and v2, but since I'm going slowly enough, I hope you can keep up with my narration and know that this v is very different from this v. This v is the image distance. If this is the image, this v is the image distance of this object. So now this is 20, this is another 20. This image will be erect and of the same length. Why will be erect? Because for the lens the magnification is v by u. V is 20 and u is minus 20. So the magnification is minus 1. That means it will be inverted from this. So in this case, the total magnification will be this magnification multiplied by this magnification, or you can see directly that the final height is in the same direction as the initial height, and it is twice as much. So we know that m1 is equal to 2. Right. Now let's try to calculate m2. So let's see what the differences will be in m2. In this case, there will be no difference for this image of this object, because in the mirror it doesn't really matter what medium you're doing it in, because the focal length of the mirror is determined by the geometry of the mirror. It does not have anything to do with the refractive index. However, the focal length of the lens is given as mu2 by mu1 minus 1 times a constant depending on the geometry, 1 by r1 minus 1 by r2. So if mu2 is the refractive index of the material of this lens, in this case glass, mu1 is the refractive index of the surrounding medium. Earlier it was air, now it's become water. So in this case, the focal length of this lens will change. So this object will not necessarily have this image, the image will be different. So the only things which will be different will be the lens images. So let's see what the focal length will be, because this is the only term that will be different. So earlier we knew the focal length was 1 by 10, and that was equal to the refractive index of the lens is given as 1.5 and the refractive index of the medium is 7 by 6. Right, so that is equal to 1.5 divided by 1 minus 1 times a particular constant. That constant depends on the radius, right? So this is 0.5. So 1 by 10 is equal to k by 2, which gives me k is 1 by 5. Now the new focal length 1 by f will be equal to 3 by 2 or 1 by 5 divided by 7 by 6 minus 1 multiplied by the same k, because that hasn't changed. So k is again 1 by 5. So that gives me, this will be 3 into 6, that is 18 divided by 14 minus 1, that is 4 divided by 14, that is 2 divided by 7 into 5, so it will be 2 divided by 35. So now 1 by f is equal to 2 divided by 35. So I can change this part of the equation. So u is again minus 20, so this will be equal to 2 by 35, which gives me 1 by v is equal to 2 by 35 minus 1 by 20. So this will be 4 by 70 or 8 by 140 minus this will be 7 by 140, so 1 by 140, so which gives me V is equal to 140. So in this case the magnification will be V by U, that is 140 by minus 20, that is minus 7. Right. So the magnification is minus 7 from this to this, and this itself had a magnification of minus 2. So the total magnification will be the product, that will be 14. So we knew that M1 was 2, we calculated it earlier, 2 multiplied by 1. Now it's 14, that is 2 multiplied by 7. So mod of M2 by M1 is equal to 7. So that is my final answer. Let's look at the next one. We are given an infinitely long uniform line charge distribution of charge per unit length lambda parallel to the y-axis. That means this line is the charge distribution. And we are given the height as z is equal to root 3 by 2a, and this particular length is a and this particular length is l. And we need to find the flux through a, b, c, d. So a better figure for this would be if I draw the figure if I was looking from this point, that is I was looking and the line charge was going outside or coming into the plane. Right, so let me draw a figure from that point of view. This is my infinitely long line charge going inside the plane. It has a charge per unit length lambda. Right, and what we want to do is we want to find out the flux in this region. So this L is in the same direction as lambda. So what we want to find out is particularly a charge through this particular region. And we know that for an infinitely long line charge, all the electric field lines are radially outwards. Like this. So we want to find out the flux passing through this region where this length is a total length A and this length going inside the plane, I apologize for the drawing, I can't really draw it in 2 dimensions, is L. So the flux will be passing through a distance in the perpendicular direction to the plane of this figure, a distance L. So the total charge which will be contributing will only be lambda L. For example, if I draw another point of view like this and we want to find the flux through this region, then all field lines are horizontal. So these lines, anything below these two, will not have any flux. So in this case, this will be the only thing which will have flux. Now the flux lines will be radially outward, completely symmetric, and we want to find out the flux passing through this particular region. So all the lines passing through this area will pass through that region. The flux line here will pass through this, and so on. Right. So now what we are given is this length is a by 2 because the total length is a, and we are given that this height is root 3 by 2a. Right. So if this is root 3 by 2 and this is 1 by 2, then for this angle tan theta will be 1 by root 3. That means this angle is 30 degrees. That means this total angle is 60 degrees. So again, if I draw this figure, this is lambda L charge, and we want to find all the flux lines passing through 60 degrees. The total flux will pass through 360 degrees, and that will be lambda L by epsilon naught by Gauss law. So the passing through 60 degrees will be this into 60 by 360, which is lambda L by 6 epsilon naught. And we are given in the problem that it is lambda L by n epsilon naught. So in this case, we should have n is equal to 6. Right? Let's look at the next question. We are given a hydrogen atom with its electron in the nth orbital, and a wavelength of 90 nanometers is used to ionize it. Right? And the kinetic energy is 10.4. So if we give a wavelength of 90 nanometers, that electromagnetic radiation will have some energy. We know that energy has to be greater than 10.4 because that energy is first of all ionizing the atom and then giving it some kinetic energy as well. And we can calculate that energy. So that's the thing we'll do first. We'll calculate that energy. We know the formula standard Hc by lambda is the energy. In this we are given that we should use 1242. So this divided by 90 comes out to be 13.8 electron volt. This is the energy of the electromagnetic radiation. The kinetic energy of the electrons coming out is 10.4. That means what is energy left, this minus this, that is 3.4 electron volt, should be the actual potential energy. This is the energy which the electron needs to be given so that it can be ionized. And for any particular shell, 13.6 by n square is that level's energy. We want to ionize it, so it goes from n is equal to some particular value to n is equal to infinity. So 1 by n square minus 1 by infinity square, that will be 0. So this is equal to 3.4, which gives me n is equal to 2. So that is my answer in this question. In the next question, a bullet is fired vertically upwards with a velocity v from the surface of a spherical planet. When it reaches maximum height, the gravity is 1/4. We want to find the escape velocity. So let's say this is the surface of the planet, this radius is r, let's say this height is h. So initially the gravity is gm by r square, finally the gravity is gm by r plus h whole squared. We are given that gm by r plus h whole squared is 1/4 of gm by r squared. That means r plus h is equal to 2r. That means h is equal to r. So this is the first thing we found out. So it is at a distance from the center equal to double the radius of the earth for the gravitational attraction to be 1/4. Then we have just asked the escape velocity. If that is v root n, then what is the value of n? So if we are throwing it at a speed v, then half mv squared would be the kinetic energy initially. The potential energy initially would be minus gmm by r. Now when it reaches this point, the kinetic energy becomes 0 because it starts falling down. This is the maximum height. We all know that the maximum height means it is not moving anymore. So this is equal to minus gmm by this total distance, which is now 2r. That gives me half mv squared is equal to gmm by 2r, which gives me v is equal to root gm by r. V escape, we all know, is the point for which this becomes greater than 0 or just equal to 0. In that case, it is root of 2 gm by r. Right, this is the standard formula we know. So if this is equal to this times something, that something is root 2, right? V into root 2 will give me V escape. So n in this case will again be 2. So that is my answer to it.